Hey everybody, Rich Everett's here with Lancaster AI. It is the last Tuesday of the month, and I'm really excited to share with you today some pretty awesome stuff. Today, I'm going to be talking about AI and why AI businesses are failing, or at least not getting as much investment as usual. And there was a couple of articles out there about this process and why it was so challenging. And so this guy here, Scott Locklin, wrote an article that kind of went a little viral in some of the areas and kind of like the cut of his jib, if you will. It was a pretty cool little story, and he looked through the Andreesen Horowitz. So you know them as some major investors, major VC firms, and they came out with an article here, The New Business of AI. And this one came out not too long ago, a couple months now. And they were talking about why they were maybe not investing quite so much in the space. So, and this guy, Scott, did a little review of it. I want to kind of go through this because I'm going to riff on it a little bit to tell you in details about some of the things and explain it to you a little bit. So whether you're interested in investing in any kind of AI companies, or you are looking at starting your own AI company and are looking at some of the challenges, this will be a good day for you. So as always, just want to remind you that the event today is sponsored by Suji. It's a home artificial intelligence platform that I co-founded, that I'm working on building. Oh, well, hello. I'm just going to say hi. We are working on building a home artificial intelligence system for the aging in place community. It helps daily living and executive function. And so, based upon my experience now over the last 3 years in putting this together, and understanding, teaching Lancaster AI now for what, over 2 years now, gone to a number of events, conferences, met all kinds of people, conversations, and I think I have a unique insight into why some of this works and why this makes sense, and hopefully everyone out here will enjoy it as well. So let's just dive on in. So he talks a little bit about these guys. Andreesen, they are major VC people in the Silicon Valley. They use a lot of buzzwords. One of the things that always irritates him, and it irritates me as well, through a lot of the people out there, you may know this, people always say AI, but usually what they mean is machine learning. Artificial intelligence is kind of like a large field to study, because within that you have things like symbolic representations and other things like that, versus machine learning, which is statistical analysis. And so when people are referring to AI today, often they're referring to deep learning, which is simply a statistical method of using neural networks in multiple layers and calculating things like backprop and all these other kinds of statistical data points. And so one of the things that he first touches on here is, in this article, the team here comes up with 3 things. They come up with lower gross margins as why people aren't as interested in investing in these businesses, scaling challenges, and defensive moats. So let me tell you what those are. So the first one is about gross margins. And here's what a lot of people don't tell you, is that cloud compute is really expensive. Oh, they make it cheap, like a good drug dealer. They make sure the first couple of hits are free. I mean, AWS hands out credit left and right to people to be able to invest in. And it's a good business practice to do that. And what they're accomplishing there is they're getting you hooked on the service. But here's what we find here, is that delivering a product meant stamping out and shipping physical media many years ago, but the cost of running software was borne by the buyer. Today, with the dominance of SaaS, the cost has been pushed back to the vendor. Most software companies pay a big AWS or Azure bill every month. In case you don't know those, AWS is the Amazon, Azure is Microsoft. Those are the 2 big cloud computing. You also have Google and a number of other minor players in the grand scheme of things. It turns out it's pretty demanding. So many of you know training a single AI model can cost hundreds of thousands of dollars. And I want to talk about that for a second, because most people don't understand that, why it's so expensive. So, and many people are there to treat this as a one-time cost, saying, hey, we trained this model, now we can put it all on all of our devices and sell it and put it out there. But that's not quite how it works, right? Since he uses this term, Andreesen uses this term, the team there, the data feeds AI models tends to change over time. So you're inputting more data into it, and it's called data drift, and so you got to continue to train on that. I wasn't familiar with the term data drift, but I understand the concept, so that's pretty cool. But, I mean, look at this. So most people don't know, but the Meena chatbot was trained on a full TPU v3 pod, so 2,048 TPU cores for 30 days. That's 1.4 mil of compute time to train this chatbot. Wow. And here's a sample conversation. Here's Meena, and there's the human all going through it. And if you read it, it's okay. I mean, it seems like the chatbot can carry on a conversation of some kind, but it's not spectacular. Now, when I did my CPOS talk back in, I think, was it this past year? No, it was 2 years ago when I was referring to the AlphaGo system that defeated the world Go champion. I referred to the training cost of that one, which was almost the same as a small power plant, right, in terms of kilowatt hours to be able to train that system. And so that's one of the things I highlighted. That was a year and a half ago, 18 months. I'll link it in this video afterwards so that you can check that out. But it was a major problem because there was no transfer learning really that you could use to make that meaningful in any other way. So again, 1.4 mil to train this chatbot. How many small startups could do that? Even maybe a seed round is probably today, they're getting bigger and bigger, but a seed round is usually running around, well, it depends. So, you have around 120 to 150,000 from your tech accelerators like Y Combinator or Techstars. And then they'll do a little bit of extra funding. They're getting bigger and bigger. I've seen $20 million Series A, $20 million Series A that they classify now. So this isn't a ton of time, but that's a lot of money for a small startup. Okay. So here's inferencing, which we talk about a lot in Lancaster AI, right? So the process of generating the predictions is also more computationally complex than traditional software. So normally with traditional software, you hit a database with a call. Like even if you're using something that has a fairly strong throughput, like a stream or something like that, usually you're using small bits of data. And that's what he's talking about here. But when we're inferencing AI, when you're inferencing deep learning machine learning, okay, let's keep the terms straight because Scott's very particular, and he may watch this someday. So usually in the deep learning space, we're using rich media. So we're using things like audio, video, images. And these types of data really consume higher than usual storage resources, but they're expensive to process, right? And so if you actually look at the board behind me, you can see that right there is a YOLO v3 model. And so you can see all the convolutions that it goes through. Now it can run in real time, but if you're running something with 1920 by 1080, full HD, you're not using any pruning or anything like that, you're not going to be able to run it in real time, okay? And so inferencing is another challenge that we're having here with the demand of these. And here, the cloud operations can be more complex than traditional approaches because there's no way to scale the cloud AI compute very well. So look at this. AI companies have to routinely transfer trained models across cloud regions. So if you're an AWS, using East, West, you have to put it out, in your Asian data center, Europe. And so you're racking up ingress and egress costs. And that's to improve the reliability, latency, and compliance. So normally, you deal with those kind of things in a software world, like in a SaaS world, and that's fine. But when you're using these massively computationally complex things, it really adds up. In fact, and this was from here, that's where this is all coming from, by the way. He's just quoting this here. So he's looking at gross margin. So this is the same thing, all right, here and here. So taken together, these forces contribute to 25% or more of the revenue that AI companies often spend on cloud resources. So 25% of your revenue, a quarter of your revenue going in just in training this. And that doesn't include other costs here. And we're going to get into those. But they are like super expensive. So I want to come back to this one, training the single AI thing. So you can train it outside the cloud, right? No problem, you could do that. But one of the things that you find here is, you know, I wanted to point this out because you could do this, you can create your own, and you won't quite have as much power, but we've talked about this in Lancaster AI before, about building your own home computing system, and you could do that. You could probably for around 5,000, you can put a really good machine together today. But one of the things you find here is that you're limited. So let's say you had to train for 30 straight days. Well, look up, this is the average electricity costs around the United States. Now, I pity folks in California, Alaska, Hawaii, and of course all these northeast places, you know, Connecticut, you know, Vermont, New Hampshire, Massachusetts. I mean, I'm sorry for you guys. We're here in Pennsylvania where we're doing Lancaster AI. We're around 8.47, so we actually have fairly decent. Now, it's even better, and I recommend this, if all of you folks out there haven't done this yet, go shopping for your electricity provider. So I go here to PA Power Switch, and in here I put my monthly usage. I put 9,000 kilowatt hours. You're probably not going to use that. The average home in America is around 1,000 to 1,500, but you could get pretty high. Now, I chose 9,000 because that's as high as I could go to get their system to actually process the data. But if you're looking at 9,000 kilowatt hours, here, that cost, and this is not this doesn't include distribution costs. So there's two costs when you have electricity. You have a distribution cost, and you have the actual production of the electricity. So this production, if you're using PP&L, which is what we use here, you have about almost $700 just for the electricity. But you can use these systems. Now, these are all for new customers. These are fixed rates, so your rates don't go up or down. And so this one's a 3-month term. And so normally you would use this perhaps if you wanted to switch during your peak usage. So often that's during the summer when people are running air conditioning, or during the winter when they're running, if you have electric heat and stuff. But anyway, you can see that the costs are right around half, 50% savings. So, and I prefer, here's a 6-month one. That's nice. And there is a 12-month. I prefer the 12-month just to average things out, but you can switch to these anytime. It's very easy to do. I'm not recommending any of these providers. I'm just showing you random people right now. But you could say if you were going to do some compute and you were an AI business, I would definitely look into if you have a PA power switch, if you're in Pennsylvania, or some kind of power switching setup. If you're really into it and you're really into the whole renewable energy fad, you can look in here. I know people don't think it's a fad, but what I'm referring to is the cost per joule and the actual investment that you make into creating the materials is often doesn't exceed what you actually get out of the system. And there's a lot of great studies on that now, where a lot of the renewable energy that we're producing is not actually as good as some of the other things we have. You generate more pollution creating the stuff to harness the free power than actually you get out of the free power sometimes. So that's something to look into. But here's what you get here. That's just an aside for all you folks out there. So in terms of anybody who's works in the field knows this, and that's all he's saying here. So if you're in his particular, he uses some colorful language here. The pricing structure of Cloud BS is designed to extract maximum blood from people with heavy data or compute requirements. They want to sell it to you. So you could, if you have 5 or 10 customers and you only have a few million rows of data and you're using a lot of this stuff, like a random forest, gradient, what is it? Gradient something model. I can't remember off the top of my head. So if you're using some simple machine learning algorithms, you can get by and you might be able to get through all this. But if you're doing any kind of rich media, you're not going to be able to do it. And a lot of people don't tell you that. So here's another problem, is that model complexity is growing. It's getting very complex. So a lot of people are trying to throw more layers at things. They're trying to come up with new architectures, and they're coming up with a whole new bunch of ways. But the compute time is not necessarily going down, like the need to compute. Now, there are some people out there doing similar things like, it's called dropout, but there's another version of it where you're only using specific points, and it helps to generalize a little bit better. So that does help a little bit. But what we're talking about here is, for most people, Moore's law is not enough. The compute resources required to train state-of-the-art AI models has grown over 300,000 times since 2012. While the transistor count of the NVIDIA GPUs, which everyone is generally using, though people are starting to transition to TPUs, has grown in 4 weeks. That's the kind of trade-off you're looking at in a lot of these businesses. And I do want to point out, and this is something that he talks about here, is that often what you're getting out of these new models is nothing that great. You get an extra 2% here, 3% there. That's why the Chinese, and one of the things that they comment in a lot of their papers and things that they do, is that the Chinese really they don't consider there to be a ton of AI research to really be done. Distributed computing is a compelling solution, but it primarily addresses speed, not cost. So you're still gonna have to spend 1.4 million. So the question is, are you gonna be able to get it done in 2 weeks versus 4 weeks? That's the kind of trade-off you're looking at in a lot of these businesses. And I do want to point out, and this is something that he talks about here, is that often what you're getting out of these new models is nothing that great. You get an extra 2% here, 3% there. That's why the Chinese, and one of the things that they comment in a lot of their papers and things that they do, is that the Chinese really they don't consider there to be a ton of AI research to really be done right now. And the Chinese are very good at scaling, taking things and scaling them. So going from 0 to 1 billion, on those kind of things. And so there's not going to be a huge amount of improvement right now in any of these particular fields, is what they're looking at. Now, here's something. Many AI applications rely on humans in the loop to function at a high level of accuracy. And so if we go back to the VC's page here, they have a whole story on this. So the first thing everybody here knows, state-of-the-art AI models involves manual cleaning and labeling of large data sets. So when I was at Brand Yourself for a while here in Lancaster, they're centered here in Lancaster, we actually had a team of people who would go through and label the data that you have, and nearly all places have that. And you can get people cheaper on places like Upwork and some other places to do this, and there's a lot of other companies out there that do it, and they'll do it very inexpensively, but you still have to have a human in the loop. And the other things that you have to consider is that the quality of the labeling really matters. So if people are off a little bit, or they mislabel something, that could have a rather serious effect, or they miss something, right? That could have a serious effect. So there has to be some quality controls on that as well. So not only are you paying for the people to label stuff, but then you're paying for someone to do the quality control on the people doing labeling. Okay, so maybe that's great. Okay, yeah, so we can do all of that. We can do that as a sunk cost at the beginning of starting the AI business. But the thing is that as time goes on, there's going to be new data coming in. You're constantly going to, that point is to generate these massive data sets so that it can constantly improve. And these are human in the loop models. So here's one. The argument that the VCs are making here is that these requiring greater cognitive reasoning, humans are often plugged into AI systems in real time. So social media companies, for example, employ thousands of human reviewers to augment AI-based moderation systems. So many of you know, for instance, at Facebook, this was a big story about 6 months ago at Facebook, which is that they have a whole team of people, and YouTube has them too, who go through, yeah, you have your AI that flags things, and they'll try to get the good portion of them, but you still have to have people to go in and review those. And those individuals were suffering from PTSD. And some of the stories are awful that you hear. I mean, there's people talking about having to watch videos of people beating puppies to death with clubs and all kinds of horrible things that really can affect you and your psyche. And they had to go through all these things. And so you have to employ those human reviewers. Now, if you're a small company doing reviews on stuff, are you going to be able to filter out that content? No. it's going to be really hard. And that's why these companies in Silicon Valley are pushing against a lot of the EU regulations to be able to force them to be responsible for the content on their site, because it requires massive amounts of human capital in order to manage that, because the AI just can't do it right now. Okay? So one of these things, I also wanted to come back here to quick talk about the labeling, because that's one of the things that I was looking at Brand Yourself. Not only did you have obviously the upfront labeling, but you had the ongoing labeling that you have. So people would go through the system, and you can go on to Brand Yourself right now, brandyourself.com, go check out their information. It's a great company, and it was fun to work with them, and I appreciate what they do, or what they did. And at that time, what you would go in, and they would give you a list of different images that it finds in your social media profile and labels as potentially bad for your brand, your personal brand. And you can just say, but you would need to go in and check them and say, oh, this is good. Oh, no, this was wrong. This was wrong. This was wrong. Oh, this is great. This is great. And so what you were doing in effect was adding to the data set, and that would go back into the data set to continue to retrain. And so that happens a lot in a lot of different products that you have and that you work with today. Doesn't matter if it's a general consumer product. Your Amazon Echo does the same thing with your NLP in many ways. So, okay. So let's keep going here. So he noticed this, Scott noticed this, and in his he talks about assuming the presence of infinitely accurate labeled trading data, which never happens, the human in the loop problem doesn't ever completely go away. So it's always amplified. And so the problem is, if you need someone, or more likely several someone's making $500,000 a year, that's a little bit more than I think you need to be making for this kind of work, but some certainly do. You might reconsider your choices. So that's for people, the people who are going in and actually understand the models. And so here, this group at the Full Stack Deep Learning, that was out at Berkeley. I told you a lot of folks about it here. Lancaster AI did that a while ago. At that time, a lot of those companies were hiring at $500,000 a year, and they'd pay for your PhD. And so if you're a small company, a small AI company, that's who you're competing with for talent. You're never going to be able to get them. When I was speaking at the Tech Council Central Pennsylvania with Annie Hughes and that group up there, I told all those businesses there, you can't compete. You won't be able to compete, because this is what you're dealing with. So let's keep looking here. The challenge is that you run into edge cases. Okay? That's always what the problem is. And so you can get pretty decent performance out of your AI models, and you can get them into a product and you can get them out there. But it's the edge cases that kill you. Because, okay, well, when you're programming, how would you handle an edge case? Well, you'd probably add a couple of extra methods, or some kind of new functional setup or something along those lines to handle that particular situation. It's a bug, you create a bug fix and then you push it out to the product and everything works. It's a little more complicated with some of the AI stuff to be able to fix that. I mean, do you need to add more data in? Do you need to maybe change some of your hyperparameters? How do you handle that kind of stuff? And so it's those edge cases. And here, this was what the VC says. Even customers that appear similar for your business, two auto manufacturers doing defect detection, for example, may require substantially different training data due to something as simple as the placement of the video cameras on their assembly lines. These systems still don't understand context. So we may understand and generalize very easily, but these will not. Okay. Okay, let's keep going here. Technical differentiation is harder to achieve. New model architectures are being developed mostly in open academic settings. Reference implementations are available from open source libraries, and model parameters can be optimized automatically. Data is the core of an AI system, but it's often owned by customers in the public domain, or over time, it becomes a commodity. And we talked about this a lot in Lancaster AI over time, in a lot of the meetings, after the meetings. it's becoming harder and harder to differentiate your visual model. So for instance, I had somebody who went to the Consumer Electronics Show this past February, January, I don't remember where it was, but it turns out that there are a lot of AI systems, AI everywhere, everywhere. And you know what? Almost all of them are running YOLO. They were all running YOLO, which means looking at it, I know almost to the exact percentage what that would, the map is going to be, the precision, recall. I can look at all those things and get an idea of that and understand the performance. And so technical differentiation is getting harder to achieve. Now, OpenAI has done some stuff in obviously the NLP space. Most of the model architectures are being done in the open, so you are able to access them. However, the licensing sometimes is difficult. So when you're doing OpenPose, which is the skeleton tracking system, that has a specific requirement that you can't use it for commercial work without contacting them. And so you're going to have to license that out. So if you want to do skeleton tracking, it's a little bit tougher there. But a lot of these, you're going to have to come up with that yourself. But a lot of these are already all set. So what that means is that if you have a small business team, awesome. If you have a small business team, you could make that work. But you're going to run into all the other same problems that we discussed here before with the humans in the loop, requiring huge amounts of human capital to scale, and the cloud infrastructure costs. So let's go back here. Let's keep moving here. Let's go back and see. So you're never going to be able to get to near zero costs on those. There's always going to be some costs in them. Okay. Oh, he even says it here. It's only getting, if you're only getting 5% better, it's irrelevant. A lot of AI really doesn't work better than a histogram via group by query. Throwing complexity at it doesn't make it better. Sometimes there's just no data in your data. It was interesting. I had a conversation with Wes. Many of you know Wes, who did a lot of who actually spoke at a couple of our events. And a lot of problems that you can handle can often be handled through machine learning, simple histogram here via group by queries or linear regressors or things like that. You don't need to go with these massive deep learning models to make that happen. And if you can, and if you can target the problem that you're solving with these more basic machine learning models, you're going to be able to get some results out of the gate, which is good, okay? And that's what he's talking about here. So eliminate model complexity as much as possible. So they've seen a massive difference in COGS, which is cost of goods sold, between startups that train a unique model per customer versus those that are able to share a single model among all customers. So eliminate that complexity. It'll help your compute. Choose the domain carefully and narrowly to reduce data complexity. And so this is where choosing what you build is going to be a huge cost saver. Automating human labor is a fundamentally hard thing to do. Many companies are finding that minimal viable task is narrower than expected. So rather than offering general text suggestions, for instance, some teams had found success offering short suggestions in an email or job posting. So they reduced the complexity down to simple things, low complexity tasks such as moderation, data entry coding, or transcription. Because these are things that AI can do quickly and easily. So if you're a small startup, you're much more likely to be able to compute that and handle that. Now, Scott here, not a big fan of Andrew Yang, who ran for political office here recently. So there's a huge admission. This is a huge admission of AI failure. All the sugar plum fairy BS about AI replacing jobs evaporates in the puff of pixie dust it always was. Really, they're talking about cheap overseas labor when lizardman fixers like Yang regurgitate the AI coming for your jobs meme. AI actually stands for alien or immigrant in this context. Yes, they do hold out the possibility of ML being used in some limited domains, I agree, but the hockey stick required for VC VC backing and the army of PhDs required to make it work doesn't really mix well with those limited domains, which have a limited market. So I'm not going to get into the political of it. It's just funny the way he came out. That's some elegant use of poetry there. So let's see here. Embracing the services. So that means meeting them where they are. Instead of doing a full stack translation service, maybe doing a more simple translation software. So one of the things that a key point you have to remember here is that you probably can't build a brain that solves all the problems. Now, we at Suji are working on that. But if that's what your goal is, you're probably going to be a service company because you have to have so many people in that loop. Or you have to have people to go do installs or all these other things. You want to get away from that because this is something you have to consider. If you're a consulting and service company, service companies are worth something like 2x yearly revenue. Whereas SaaS and technology companies are worth 10 to 20x revenue. And again, he says this is why the WeWork, you remember that company that almost went under, kept trying to position his pyramid scheme as a software company, even though it involved far more people than it did software, kind of. The implications are huge. AI raises done by A16Z, which is this VC company, one of the best in Silicon Valley. So people listen to what these folks say, and they should. It's going to be at much lower valuations. If it weren't clear enough, they said it again. They feel that AI, to an extent, has become a service business. AI has become a service business. So that's where you got to look at this. But VCs love software businesses because you work hard up front to solve the problem, but you just scale and the revenue continues to increase. And that's why you get these 10, 20x revenue valuations. Okay? So, what did it come out to? Well, Andreesen and Horowitz come out here and they say, oh, well, we're going to continue to invest in these kind of companies and everything looks great, everything looks awesome. You got to follow the money. Follow the money. Because based upon what Scott found and some of the stuff that I'm finding, they're only really investing in a couple of small AI companies, if you will. And so they're not putting their money into AI as much anymore. And a lot of other people aren't. So if you would used to be able to go into a Silicon Valley meeting and say, hey, I'm doing some kind of AI. I met somebody at the Full Stack Deep Learning Bootcamp who, and I won't mention names, but he told me a story of him walking into a VC meeting and he said, I have an idea and that's it. And they gave him $500,000. He walked out of that meeting with $500,000 and it had to do with AI. You wouldn't be able to get away with that now. That's just not how a lot of these companies are working. So they're more interested in crypto and blockchain than AI right now. They're playing that long, sounds like. And so that's really all I wanted to talk about with this. That takes us to about the half-hour mark. It tells us, you got to build let's talk about the moat here. If you're going to build a business, plan for high variable costs. Okay, these are from the VCs, what they recommend. Plan for high variable costs if you're building an AI business, because you're going to have all those humans involved in it. It's going to be a problem. Embrace the services. Building hybrid businesses is harder. Services can be a great way to kickstart a company's engine, but you're going to have to move over to software. So you're going to have to plan for a change in the tech stack. So there's going to be tools that are going to make these things easier. So again, very much like your AI systems today, you can compete with the bigger people because a lot of the models don't change right now. A lot of the tools are changing that you can really just drag and drop into them. And so Intel has a great new one. For instance, they just came out with a new skeleton tracking system. They're selling the license, but it works with their cameras, and it's pretty amazing what it can do. Google just came out with Google Pipeline, and I don't know if you've seen that. Pipeline. MediaPipe, sorry. Yeah, so you can do these kind of things with MediaPipe. All of these. Object detection and tracking. These are all built into the neural network models, and they can be run on mobile devices. Now, I wish they didn't make it for Android, but you know Google's going to continue to try to drive that traffic there. There are some things that you can use on desktops and other systems. But it's becoming easier and easier to drag and drop things in. So planning for change in the tech stack. Now, building defensively the old-fashioned way. Good products and proprietary data almost always build good businesses. So they're saying that you can make it, but don't expect to. Here's two examples that they invested in. Shield AI being one of them. Develops AI software and intelligent hardware products that protect lives. Sounds like military applications to me. Nova AI. Remember, I talked about this in my CPOS talk back in 2018, where I said that all the jobs aren't going to disappear. It's not going to be quite like that. We are going to get a lot more human-machine teaming. Well, here it is. Well, I was right 18 months ago. So this is called HiveMind. That's one of the ones that they looked in. So you can see that they have a product, and they have a very specific area that they're targeting. Doesn't look like it's trying to do too much. And then this is the other one. This is SigOpt. So this looks like very specific. So experiment insights, optimization engine, enterprise platform. Let's see here. It looks like they're very specific in what they're offering to the enterprise services. They have a lot of industries, but they're very specific. Interesting. So they're selling the actual tools, like AutoML kind of tools. All right. So those are the two big ones that they put in there. And this refers to data moats. This is another one by Andreesen Horowitz. Treating data as a magical moat, so saying you have great data, it just doesn't work anymore. And I would encourage you to go through this. I'm going to actually I'll put these in a link afterwards. So that's about it for today. I'd like to close it out there. If you have questions, I'm going to hit the chat room, and we can chat for a little while and see what's going on. So thank you, everybody. If you're thinking about starting an AI business, these are some things to think about. I'd love to talk to you more. I'm always looking for people. Right now, I'm building some stuff with Unity and C#. If you're looking to work on some AI stuff, I could really use some assistance there, and I'd be happy to talk with people and figure out some ways we could work together. Otherwise, I hope everybody has a wonderful night. Cheers. All right, what do we got here? That's funny. There are some companies that will sell you a certain rate that sounds favorable, but the monthly payment will be much higher. Definitely use the PA power switch. Yeah, PA power switch. Yep. Yeah, that's yep, that's this one here. Definitely use this site. Very good, very good. Let's see here. Limiting the scope. Yep. One thing that amazes me is what we think by itself. AI will replace all logic. It can replace or do things, but not now. Yeah. Yeah, obviously there's a limited aspect to it and what it can accomplish. And AI was just being oversold, I think, and people thought it could fix everything. it's just not going to work, right? So we have this argument all the time. I would really highly recommend, if you want to know more about AI and kind of where the space is, I'd recommend two things. I'd recommend checking out Lex Friedman online on YouTube. He has some absolutely amazing interviews. He just interviewed, let's see, Jack Dorsey. He's interviewed Elon, I believe. I'm not sure about that. I think, yeah, he's interviewed Elon. He's interviewed almost anybody who's anybody. Richard Penrose, all kinds of people. Anybody who's anybody in the AI space has been on his show, and it's really good. And I would highly recommend checking that out. You can just put it on in the background. I put it on when I go outside, and last weekend I had to get a garden ready for the family. And so I was out there, I just had my headphones on, and I just had Lex going on in the background. I learned all kinds of awesome things. So I would highly recommend that one to understand about where AI is and what it can accomplish. Now, Lex is kind of an optimist. He's a little bit of an optimist about things. Not all of his people that come on the show are. So there's a question about where we are with AI and how long it'll take to get close to human intelligence. I discussed this in my last talk, How Close Are We Human AI? That was actually the whole talk that I discussed at the last CPOSC. And I still think we're a ways away, but we will be able to hit what Baudrillard called the simulacra. In, my guess is 20 years. We'll be able to simulate very well human behavior. It'll look like a human, but there'd be some things that it won't have. Cool. All right. Congrats, Jerry. Excited for you, man, that you got your AI domain ready and getting started. Good stuff. What kind of stuff are you doing? Let's see what we got here. What? What else people got out there? Anything good? Here's his TLDR. Deep learning costs a lot for marginal payoffs. Machine learning startups generally have no moat or meaningful special sauce. Machine learning startups are mostly services, not software businesses. Machine learning will be most productive inside large organizations that have data and process inefficiencies. So that's why this guy here, SIGOPT, they're looking for large organizations. They're targeting enterprise. Here, they're targeting big enterprises. You know who uses these kind of things? It's military. NASA might be interested in something like that. Large research organizations. So, cool. All right, well, I'm excited. I mean, I can keep talking. If anybody has any questions, things they want to talk about, I love talking about this stuff. Trying to think anything else that's happened here in the last month in the AI space. Anybody have anything they want to throw out there? I'm trying to think here. So, let's see here. I did get this. Manning Publications, the Unity in Action. It's a little bit older, but it's a great resource. This goes into what we talked about last month with the Unity and ML agents and doing the reinforcement learning stuff. And it was really good, and I'm really looking forward to Unity. I'm actually working on some stuff there right now. It's going pretty well. And if anybody has any Unity experience, definitely could utilize a little bit out there. But definitely some cool stuff. I'm going to show you the Intel. See if I can get this up here for you so you can see it. So this is their new skeleton tracking SDK. Runs on Windows and Linux, and it thankfully has a Python and Unity wrapper on it. Highly accurate 2D and 3D poses. No GPU needed. CPU only. Woohoo! Easy start. I mean, you should see the video. It is awesome. And it'll give you 18 points of tracking. Here's the code. I mean, look at this. Here's the Python code. So you open it with OpenCV. We instantiate the API. Get the model using the path. Boom. There's the model. Looks like a floating point 32 model. Load the model. So this is just the path. Load the model, path, and then run the thing. Boom. That's it. Runs in real time. It's pretty amazing. I gotta say, it's pretty amazing. I contacted their team. It only runs currently right now on x86, which kind of stinks because there's not many edge devices that use x86. Almost everything's ARM, so including the Jetson Nano and stuff. So it'd be cool to see. You can get a free trial if you want to try it. You just need one of the Intel RealSense cameras. We have the D45. Oops. I don't know. Can't turn the volume down. So it wasn't too bad. It's pretty close. It's pretty close. That's so funny about the blockchain. Yeah, Grand Jerry, you're both right. Blockchain's the new AI term. I'm just gonna throw blockchain at it. Yeah, it's all crypto. All crypto. I mean that needs a lot of compute too. So we'll see. We'll see how that all goes. I'm along on some other things, which I think are gonna take off, but. Let's see here. Yeah, this is pretty cool, and the media pipe, I have to say, is actually pretty cool. I was really interested in this one, the 3D Objectron, which requires a GPU. But look, it gets a floor plane based upon the image, and it's able to do it. But it only can work for shoes and chairs right now, which is kind of limited, right? Let's see what else we got here. I'm probably going to use this one here, but I had to figure out. See, here's the thing. So we know, having done AI for a while, that the reason that this is tracked so well is because it's on a white background, and the background doesn't change very well. And so it stands out really well. You know, it's like a green screen almost for this, but it does do great work there. And so this is very interesting. I'd love to see this work in something else. We'll see. I'm not sure yet how to build this on other things outside of Android, but I'm sure there's a way. But I'm going to be looking into that. They have all kinds here. Face mesh, face detection, hair segmentation. So if you wanted to do hand gestures, you could. Here's the code. Just plug it in. Boom, you're done. You can have a hand gesture AI app in a couple of minutes. Okay, a couple days. So. NVIDIA container on Ubuntu, and it seems to work for TensorFlow. Yep, it should work. Yeah, shoes and chairs. That's right, Jerry. Tomorrow. The world of tomorrow, today. So. All right, everybody. Let's see what else. I really don't have anything else for the day. Somebody put MobileNet on a web interface. I am 20% merged. That's funny. That's funny, Grant. I use MobileNet right now on one of my edge devices, and it does pretty. It's not bad. It's not bad for person detection. generally okay. But I'm gonna see if I can find something a little better. We'll see. Problem is that mobile network's so great in real time. You know, it's tough. It's tough to say no. But cool. All right. Well, it was awesome talking to everybody. Thanks everybody for coming out. I had a great time. It's good talking to everybody. And hopefully we can do this again soon. In case you're wondering, there'll be another episode of There Is No Spoon on Thursday. I do it every Thursday night. I don't know what the topic is. Generally, I think of them the day before. If I don't have a topic, I'll run with continuing the Stephen Wolfram dive into his universal theory of everything. And, that's probably going to be a 40-part series. So we have plenty to go through there. Otherwise, may talk about some Carl Jung, may talk about, whatever pops up. Sometimes I talk about AI too. So thanks a lot, everybody. I'll catch you next month for Lancaster AI.